Okay, that's it. Yep, it's time. So I'm going to share my screen. Okay. All right. Yes. So today, let's see what we're going to do. Okay, today we will be looking at some number patterns in which we are going to be adding consecutive numbers. Okay, I hope you all know what is the meaning of the word consecutive. Huh? Consecutive actually means one after another. All right, so if we are talking about consecutive numbers, then it means if I have one, then the next one will be two, the next one will be three, the next one will be four. Yeah, if I say consecutive even numbers, then the first one will be two, the next one is four, the next one is six, the next one is eight. Okay, so consecutive means one after the other. Then we are also going to be doing some word problems involving models. Yeah, so all these are listed here: part whole models, comparison models, stacking models. All right. Okay, I think yeah, we have one more person trying to come in. I'm trying to let Zafira in now. Yeah, I think she's trying to get in. Yep. Okay, so with that, let's move on. Okay, now what happened to Viana? Viana, you have disappeared as well. Okay, are we ready to start? Now, uh, hello, Levine. Okay, now I've actually inserted this slide here, okay, because of question 1 that you have in your worksheet. All right, question 1 that teacher Bern has actually put in involves triangular pattern. All right, now a triangular pattern looks very much like a staircase. Okay, it just goes up and up and up. All right, so it's like a staircase going upwards. Now, when we are talking about staircase, right? Actually, triangles come from half of a rectangle. Okay, let me just show you how it looks like if I were to represent like numbers using little squares. Okay, so if I arrange them, okay, it will look something like that. For example, let's say, okay, we start with something very simple. For example, I say we want to find what is 1 plus 2 plus 3 plus 4. Okay, now children, when the numbers are very small, like these are only 4 numbers, right? Of course, we won't even bother to look for a formula. We will just add straight away. So 1 plus 2 plus 3 plus 4 is actually 10, isn't it? All right. But the thing is, what if somebody asks you, what is 1 plus 2 plus 3 plus 4 plus 5 all the way until 259? And then we die, right? Because if I'm going to use that simple way of adding every single number one at a time, then I will never finish. Okay? All right. So there is actually a way to get an answer. So let's look at a pictorial representation. So I'm using little squares to show you. It's not coming out. Okay, so you see, these are the squares. The first square, and then after that, 2 squares, and then after that, 3 squares, and then after that, 4 squares. Okay, so that is supposed to represent our 1, 2, 3, and 4. Now, but then the thing is, if I want it to look like a rectangle, I can put in one more set of 1, 2, 3, and 4. So I'm going to put another set in. Okay, one more set. No, Nicole, when you join it this way, you'll find that you end up with a square, right? A square will not give you 2 sets of 1, 2, 3, 4. When I need 2 sets of 1, 2, 3, 4, it will look like that. Do you see it actually becomes a rectangle? Okay. So just now, children, when you all saw Nicole cut over there, right? When you cut over there, you will find that this side, the pink one, is actually only 1, 2, 3. Then the yellow one is 1, 2, 3, 4. That will form a square. But if I want 2 sets of 1, 2, 3, 4, it becomes like this. It is not a square, it is actually a rectangle. Okay, it is actually a rectangle. And why do we need do we actually need to know the rectangle? Because which you will learn later on in this year, we know that the area of a rectangle is actually the two sides multiplied together. Okay, so okay, it's never a square. Now, what is the length of the square? The length of the square is the horizontal line. Okay, the horizontal line over here. And if you count the number of squares, it is 4 squares. Okay. Otherwise, if I want to call it a triangle, that is actually known as a base of a triangle. The bottom of the triangle is the base. Okay. Now, what about the breadth of the rectangle? The breadth of the rectangle is the upright line. Okay, in which when you count, it is not 4 anymore, it is actually 5. Why is it 5? It is because when I plonk in another set, right, of 1, 2, 3, 4, you notice the pink one has to sit on top of the yellow one. So there will always be one extra square, always one extra. Okay, so the height or the breadth, okay, is actually 5. Now, the formula for area of a rectangle is actually taking the two sides and we multiply together. So the area of the rectangle is actually known as length times breadth, and that will get me 4 times 5. Okay, 4 times 5 will get us 20, right? Okay, just now I saw Ariana giving us the answer for 1 plus 2 plus 3 plus 4 equals to 10. So do you realize that two sets of the triangles form a rectangle, which is 4 times 5, which is 20. So if I just want one set, I must divide by 2. Okay, so one set I divide by 2, I will get 10. Get it? Okay, now with this understanding, right, now we are going to take a look at our question 1. Okay, we take a look at question 1. Okay, see, this is question 1. But question 1 actually shows you 3 patterns. The first pattern is not just 1. The first pattern is already 1 plus 2. Okay, do you see 1, my yellow one, and then plus 2, the purple one. All right, now look at pattern 2. Pattern 2 is 1 plus 2 plus 3. Okay, now the reason why I don't want to add the total yet is because I want to show you this whole series of numbers and where is the beginning, where is the end. All right, Levin has actually kindly filled in for us. So for pattern 3, yes, we have 1 plus 2 plus 3 plus 4. Okay, now look at the question. The question is asking for pattern 27. Do you know pattern 27 will be 1 plus 2 plus 3 until where? Okay, Levon. Yeah, because that was the name I have. And then suddenly when I see your name in this, right, you have actually changed it to I-N, L-E-V-I-N. So that's why I'm calling you Levin. Okay, but it's still Levon, yeah? Okay. All right. Okay, so firstly, who can tell me 27 triangular pattern is actually 1 plus 2 plus 3 up to which number? Ariano, your hand is raised. You wrote the 406 is the final answer, right? But what is that last number we are talking about? Nicole, you cannot just put IDK, right? We were talking about already. So like pattern 1 ends with 2, pattern 2 ends with 3, pattern 3 ends with 4. So pattern 27, the last number must be, oh dear, and then nobody is telling me. Can you all write onto the screen? You see, I can see Levon write 28. Very good. Very, very good. Yes. So pattern 27 is actually 1 plus 2 plus 3 all the way until the last one is 28. Okay, the last number is 28. Now, just now the previous slide I was explaining to you, right? This triangle is actually one set of the rectangle. The rectangle is made up of two sets, remember? And then the two sets, I will need the length and the breadth, right? So the length is always the last number. Okay, the length is always the last number, which is your 28. All right. Then the breadth, remember one more seat on top, right? Will be taller than the length by 1. So it will be 29. Okay, so we actually have these two numbers. When you take 28 and multiply by 29, you will actually get the total, which is the rectangle. And since I am only interested in one set, I will have to divide by 2. So I have it. So 28 times 29, then I divide by 2. I should get 406. Okay, so this is the so-called the magic formula that Bern wanted you all to learn. Okay, so actually once you learn it, you can go to school and go and test it out on your friends. You see whether they know how to do or not. All right, okay, all right. So let's, okay, I can see that yeah, 28 times 29. Yes, Nicole is actually trying to multiply, right? Yeah. You have to take 28 times 29 first. Yeah, and you will get 812. Okay. After you get 812, that is actually two sets of this pattern. Then you must divide by 2 to get one set. All right. Okay. Now, let's take a look at question 2 now. Yeah. Okay. Let's look at question 2. Okay. Now, question 2 is actually the same pattern. Do y'all know that it's actually the same pattern? Or you didn't realize? Okay, I have people who raised the hand. Yes, children. Ariano and Viana. Yes. Can y'all, yeah, would y'all like to write it down? Like, what? Why is it a question mark? Why is it a question mark? Okay, I think I have to go into the screen. Somebody is talking to me. Oh, okay, okay. Levon, you need to run off for a short while. You just go and then quickly come back, okay? All right. Okay. Okay. Now, Ariano, yes, you wrote 8 as your answer. But the thing is that how do we know that it is actually 8 people? Okay. Firstly, you must know when we talk about shaking hands, right? Okay. If I shake your hand, it is exactly the same as you shake my hand. Okay. So if I say the two of us are shaking hands, actually there is only one handshake. Okay, there is only one handshake. But one handshake involves 2 people. When you have only one person, you don't shake hand with yourself. That means we don't use our left hand and shake hands with the right hand, right? Okay. All right. So let me just show you the pattern. Okay. Imagine. Okay, now it doesn't want to come out. Okay. Imagine there are 2 people, okay? So person A and person B. Now, you need 2 people in order to shake hands. So when you have 2 people, what will happen is, okay, I will draw a line to represent shaking hands. Okay, like that means there is only one handshake. Okay, there's only one handshake. But what if I add one more person? When I add one more person, I will have 3 people. Okay, so now I have A, B, and C, these 3 people. Okay, then let's start with A again. We always start with A, right? So A will shake the hand of B. A will also shake the hand of C. So you will have 2, correct? Now, what about B? Of course, B will also shake A's hand. But the thing is that because we already counted A shaking B's hand, so you don't want to double count, you don't want to repeat. So now we just talk about B shaking C's hand. So plus 1. Do you realize that now it's all connected? C has already been connected to A because at first we already used